Okay, so the first problem is problem number 5, and it says a singular force F applied to an object of mass m1 produces an acceleration of 3 meters per second squared. The same force applied to a second object of mass m2 produces an acceleration of 1 meter per second squared. And part A is asking us what is the value of the ratio of m1 over m2. So how we're gonna do this is we're gonna first I'm gonna write down my acceleration. So my first acceleration is equal to um 3 meters per second squared. My second acceleration is equal to 1 meter per second squared. And then here now I'm gonna write I'm gonna from this formula from F equals ma, I'm gonna rearrange this to get m, and then I'm just gonna write it in this form. And that's pretty much how you do this problem. So rearranging this, we divide both sides by a. So then we'll get m equals f over a. And then now you just plug in your values and yeah, you'll get your answer. So m1 is going to be equal to f over a. Oh, well, it would be a1. So it'd be 3. And then we're dividing by m2 is going to be another fraction, so I'm going to skip this step. So I'm just going to multiply already, because when we divide fractions, we're actually multiplying the second fraction, multiplying by the reciprocal of the second fraction. So we got f3, and I'm just writing f because it's the same force, so there's not like f1 or f2 the same force. So 5 over 3 times m2, which is going to be the reciprocal, so that's going to be this acceleration, so 1 over f, and these f's will cancel out, and then your answer is just 1 over 3. And then part B is telling us if m1 and m2 are combined into one object, find the acceleration under the action of force F. So I kept this from the last part because what this 1/3 is telling us that m1 is equal to 1/3 of m2. That's what this is telling us. So then now I'm gonna find out what both of these are equal to when you add them. So I'm gonna write it as big M equals m1, so that's 1 over 3 m2, and then plus just m2. So like that, and this is gonna be equal to 4 over 3 m2. And then now what I'm going to do is I'm going to find the acceleration. Now that we have the mass, I'm going to find the acceleration. So again, like we did in the last problem, we're going to set up an equation. We're going to use this F equals ma, and then rearrange to get a by itself. So divided by m. So then a is equal to f over m. But we don't know what f is. But actually we do know what f is, because we are told that f is equal to m2. We're going to do it with m2. So f is equal to m2, the mass, m2 times its acceleration. So that's just 1. So that's f equals m2 times 1 meter per second squared. And I'm going to include the units here so that you guys can see how this is going to cancel out. So now we know what f is and we know what m is. This should be a big M, actually. That just looks like I scribbled that out, but that should be all of these should be big M's, because we're finding the M because we're using the mass of both of the objects. So now we have this. So now we have everything that we need. And now we're just going to plug everything in to this equation right here. So our acceleration is going to be equal to the force, which is this. So m2 kilograms times 1 meter per second squared all over 4 over 3 m2. And then I'm going to use the units for that as well. And now what you're going to notice here is that these things cancel out. So m2 is going to cancel out with m2. And then you're really just left with 1 meter per second squared all over 4 over 3, which again, if you divide by a fraction, you're just multiplying by the reciprocal. So this is really just 1 times 4 over 3, which is going to get you, hold on, that is not right. I meant 1 times 3 over 4, which is 0.75. And don't forget the units, so it's meters per second squared. And that is how you do that problem. Okay, so the next problem says 2 blocks each of mass m equals 3.5 kilograms are hung from the ceiling of an elevator. The elevator moves up with an acceleration of 1.6 meters per second squared. And in part A, we are asked to find the tensions of the first string and the second string. So the way that we're gonna do the way that we're gonna find the tensions is we're first gonna set up our sum of all the forces equation. And the forces in this case, the forces are gonna be the tension and gravity. So it's gonna be T1 because we're working with T1 plus the force of gravity is going to be equal to the mass times the acceleration of these two masses. So also, since we're talking about these two masses, we're actually going to put a 2 in front of this m because it's two masses. Now, Fg can be rewritten as negative mg. So we're going to go ahead and do that. And again, since we have two masses, it's going to be negative 2 mg in our case. So we have T1 minus 2 mg equals 2 ma. And since we're solving for T1, we're going to add 2 mg to get T1 by itself. So add on both sides. Now we have T1 is equal to 2 ma plus 2 mg. Now we already know everything here, so now we're just gonna plug in everything. I'm not gonna write down all the units, so I'm just gonna write down the numbers. So we have 2, and then the mass, which is 3.5, and then the acceleration, which is 1.6, plus the mass again, which is 2m, so it's 2 times the mass, and then times the acceleration due to gravity, which is 9.8. And usually this is negative, but we already had a negative right here. So T1 then is going to be equal to, I forgot, but I have the answers right here. It's going to be equal to 79.8 newtons. That's how you find T1. Now, to find T2, it's going to be almost exactly the same. So we have this equation again, and we're going to write down the forces again. So now we have T2 plus the force of gravity equals the mass times the acceleration. But if you look at T2 right here, it's just pulling up this single m. So it's just going to be m instead of 2m. So now we write this again. Remember, the force of gravity can be rewritten as negative mg or minus mg. So now we have T2 minus mg equals ma. Isolate T2, so we're going to add by mg. We get that T2 equals ma plus mg. Plug in everything that you know now. M is 3.5. the acceleration due to, not the acceleration due to gravity, the acceleration of this is 1.6 plus the mass, which is 3.5, and then the acceleration due to gravity, which is 9.8. And then you'll get that T2 is equal to 39.9 newtons. Now for the final one, I mean, not the final one, but this was like part A. Now we're doing part B. Part B is asking us, what is the max? I should not have erased that. Now it's asking us, what is the maximum, okay, actually, no, I'm gonna redo that, okay. But we're doing good for right now. What does that have? Okay, so then part B is saying if the string can withstand a maximum tension of 85 newtons, what maximum acceleration can the elevator have before the string breaks? So the way that we're going to do this one is we're going to do it almost exactly the same again. So we're going to set up our our Newton's second law. So we have the sum of all the forces is going to be equal to mass times the acceleration. Now, again, it's going to be the tension plus the force of gravity is going to be equal to 2m, so 2ma, and then rewrite this fg. It's going to be t minus 2mg because we have two masses hanging equals 2ma, and since we're asked about the acceleration, now we're just going to isolate for acceleration. So we're going to divide by 2m over here. We're going to divide by 2m over here. Now we have acceleration is equal to t minus 2mg all over 2m. And we plug in all our values. That's going to be t, which we are told is 85 newtons. So 85 newtons minus 2. The mass is 3.5 times the acceleration due to gravity, which is 9.8, all over 2, and then the mass, which is 3.5. And plugging that into the calculator, you will get 2.34 meters per second squared. Now, I'm not writing the newtons because I'm trying to do this stuff really fast so I could fit in a lot of problems in the video, but if you're taking physics, then you'll know how you end up with these units, or you could just track it, like, this is going to be in newtons, this is in kilograms, this is in meters per second squared, this is also in kilograms. So it, like, this stuff cancels out. I mean, okay, so we have a weight of 325 newtons suspended by 3 wires. This is the first wire at an angle of 60 degrees. This is the second wire at an angle of 20 degrees. And this is the third wire just going straight down. And we are asked to find the magnitude of the tension in each wire if the system is in equilibrium. The first thing that I'm going to do here is I'm going to find what these angles are relative to the horizontal. So this angle right here for the second wire is just going to be 20 degrees. And this angle right here, relative to the horizontal for the first wire is just going to be 60 degrees. So now I'm going to set up my equation. So I'm going to use Newton's second law. And since I know that the object is in equilibrium, that means that it's not going to be accelerating. So I know that this side is going to be equal to 0. And then now I'm going to split up my components into the x, to the horizontal and the vertical direction. So let's do the ones in the horizontal first. So the sum of all my forces in the x is going to be equal to 0. And now I'm going to look at the forces acting in the x direction, which are only going to be the horizontal component of T2 and the horizontal component of T1. So now I'm going to write that down, and I'm going to make the up and right direction positive. So then T2, and then the horizontal component of that. So T2 cosine of 20 minus T1, because that one's going to be pulling it that way, minus T1, and the horizontal component of that, which is going to be cosine of 60, is going to be equal to 0. Now I have this equation. I'm not going to do anything with it yet. Now I'm going to go on and do the sum of all the forces in the y. And again, this object is in equilibrium, so it's not going to be accelerating, so they're going to be equal to 0. And in this case, all of these are working in the y direction. However, T2 and T1 are pulling up while T3 is pulling down. So I'm going to have T2, only the vertical component, so T2 sine of 20 plus, because this one is helping it, T1 sine of 60 minus the 325 newtons, because that's pulling down. So it's going to, it's going in the opposite direction. So 325 newtons is equal to 0. And then now what I'm going to do here is I'm going to solve for one of these variables, and I'm going to solve for T2. So what I'm going to do to this equation right here is I'm going to rearrange it to get T2 in terms of T1. So that is going to look, so if I rewrite that, that's going to be T2 cosine of 20 minus T1 cosine of 60 is equal to 0. And to get T2 by itself, I'm going to add by T1 cosine of 60. So I'm going to add. So then now I have T2 cosine of 20 is equal to T1 cosine of 60. And now I'm going to divide by the cosine of 20. So then I'll end up with T2 equals T1 cosine of 60 all over the cosine of 20. And then now what I'm going to do here is I am going to plug in this T2 into this one. And then the only missing variable that I have is T1, so I just solve for T1. So go ahead, so plugging this in, I'm going to get T1 cosine of 60 all over the cosine of 20, multiplying that by the sine of 20. And then we're adding T1 sine of 60 minus 325 newtons is going to be equal to 0. So I'm going to plug this into my calculator to get these values. So it's going to be the cosine of 60 over the cosine of 20. And then this value, you're going to multiply it by the sine of 20. So you're going to get T1 multiplied by 0.18198 plus T1 and then sine of 60. So sine of 60, T1 multiplied by 0.86602 minus the 325 newtons equals to 0. And I'm going to combine like terms. So we're going to get T1, and then I'm going to add these numbers. So I'm going to get T1 multiplied by 1.048 minus 325 newtons is going to be equal to 0. And then now what I'm going to do here is I'm going to isolate T1. So I'm going to add both sides. I'm going to add 325 newtons to both sides. So now we have T1 multiplied by 1.048 equals 325 newtons. And then to finally isolate this, I'm going to divide both sides by 1.048. And you'll end up with the final answer of T1 is equal to, so we have 325 divided by 1.048. T1 is equal to 310.11 newtons. So that is your answer for T1. Now I'm going to go ahead and solve for T2. So I'm going to plug this value into this. So erasing all of this. Now I have, so it's going to be 310.11 newtons times the cosine of 60 all over the cosine of 20 is equal to T2. So now all we have left to do is plug this into the calculator. So we have 310 newtons, 310.11 newtons times the cosine of 60. That is going to be all over the cosine of 20. And your final answer for T2 is going to be 165.006 newtons. I should have circled this whole thing. And then we are also asked for T3, but we know that T3 is just going to be the weight. So T3 is just going to be equal to 325 newtons. And that is how you solve that.